Balloons on a wall. You shoot arrows straight up. One arrow can pop multiple balloons if they overlap. What's the minimum arrows to pop them all? This is LeetCode 452, and it's a beautiful greedy problem. Let me show you why. Each balloon is a horizontal range on a number line. Start to end. You shoot an arrow at position X, it pops every balloon where start is less than or equal to X and X is less than or equal to end. One arrow can pop multiple balloons if their ranges overlap at that point. Your goal: find the minimum number of arrows to burst all balloons. Visualize it. 4 balloons shown as ranges. 1 to 6, 2 to 8, 7 to 12, and 10 to 16. Notice 1 to 6 and 2 to 8 overlap. 7 to 12 and 10 to 16 also overlap. Shoot an arrow at X equals 6, it hits both the first group. Shoot at X equals 11, hits both in the second group. 2 arrows, all 4 balloons popped. But how do we find this systematically? Here's the greedy insight. Sort all balloons by their right edge, the end point. Place your first arrow at the right edge of the first balloon. Any balloon whose left edge starts before that point gets popped for free by the same arrow. Keep scanning. When you find a balloon whose start is beyond your current arrow, you've found a new group. Place a new arrow at its right edge. Repeat. After sorting by end, 1 to 6 comes first, then 2 to 8, then 7 to 12, then 10 to 16. First arrow goes at X equals 6, the right edge of the first balloon. Does it pop 2 to 8? Yes. Start 2 is less than 6. They overlap at 6. Next, 7 to 12. Does 7 reach our arrow at 6? Number 7 is greater than 6. New group. Place arrow at 12. Does 10 to 16 reach? Yes, start 10 is less than 12. Opt. 2 arrows total. Let's walk through it. End starts at 6, the right edge of the first balloon. Arrow count starts at 1 because we always need at least 1. First balloon, start 1 is less than or equal to 6. Yes. Same arrow. Start 2 less than 6. Yes. Same arrow. Start 7 less than 6. No. 7 is beyond. New arrow. Count becomes 2. Update end to 12. Start 10 less than 12. Yes. Same arrow. Done. 2 arrows. Why the right edge specifically? Because it's the tightest constraint. The first balloon must be popped somewhere between its start and end. If you pick the rightmost point, you maximize the chance that the next sorted balloon also overlaps there. Pick any further left and you might miss balloons that start later. This is the classic activity selection trick. Why does raise start at 1 and not 0? Because we always need at least 1 arrow for the first group of balloons. The loop only increments raise when it finds a balloon that the current arrow can't reach, meaning a new group. Compare this with non-overlapping intervals where uns starts at -1 because the loop compares the first element with itself. Different initialization, same greedy core. The code. If empty, 0 arrows. Sort by end using a lambda, P1 index 1 less than P2 index 1. Set end to the right edge of the first balloon. Raise starts at 1. Loop through all balloons. If the start is less than or equal to end, same arrow covers it, continue. Otherwise, new group. Increment raise, update end to this balloon's right edge. Return raise. Clean, minimal, greedy. Important edge case. Balloons touching at 1 point. 1 to 2, 2 to 3, 3 to 4, 4 to 5. You might think 4 separate balloons, 4 arrows. Wrong. Arrow at X is equal to 2 pops 1 to 2 and 2 to 3 because the condition is less than or equal. 2 equals to means it reaches. Arrow at X is equal to 4 pops 3 to 4 and 4 to 5. Just 2 arrows. That less than or equal makes all the difference. Time complexity, O of n log n from sorting. The loop is a single pass, O of n space, O of 1. Just 2 variables, end and raise. No extra data structures. Simple, efficient, optimal. This is the interval greedy family. Sort by end. Process left to right with greedy choices. LeetCode 56 merge intervals. 57 insert interval. 435 remove overlapping intervals. 452 burst balloons with arrows. All use the same core trick. Master this pattern and the whole family becomes easy. If this visual explanation clicked, hit like and subscribe. Drop a comment which interval problem should I cover next. See you in the next one.